and brought it to iPhone, iPad, and we actually have a functioning Android build that we don't know what to do with. You know, I wanted to share with you a little bit of the trials and tribulations that we had while developing this application. So, why would you want to go cross-platform? I think that's like the #1 question, and it's kind of a no-brainer. You look at the industry right now, and there are a lot of success stories, right? You look at Max and the Magic Marker, which has gone from the Wii all the way to the PC, the Mac on Steam. You know, it's on iOS now, and the revenue potential there is kind of incredible. You really want your game in front of as many eyeballs as you can get it, and there's no better way to do that than to put it in front of, honestly, more people. So, obviously, Anomaly did this. I actually really enjoyed that game, and hopefully our little guy, Bitey, will be making his appearance on iOS very soon. So, basics, right? In the talk, I kind of want to go through high level to low level, right? At the top, I want to talk to you about some good software engineering practices, not coding for today, but coding for tomorrow, right? Dealing for the feature request, dealing for the weird platform that you didn't expect you would have to support. After that, I'm going to start talking a little bit more in detail about how to structure your code in that regard, some good software engineering practices. As part of this, actually, you all are Facebook members, right, on the Facebook group? Yep. Okay, on the Facebook group, I'm actually going to post Muse platform, which is our static class that we use to really help us doing cross-platform development. It's not completely fleshed out yet. You'll notice that the Android components are sort of sparse. Obviously, it's very iOS heavy at the moment, but I'll keep it updated for you. I'll put it in a Git repo for you guys. You know.
Quick question is the only way to access that being part of the Facebook group?
Yeah. If you're not part of the Facebook group, just come to me, give me your email.
If it, for whatever weird reasons, like, so haven't got a hold of my Facebook avenue, even though we have to make games for it. Is there any other way to access it?
What I'll do is I'll put it on GitHub, so I can update it for you guys, just so you guys have what I'm working with. After that, I'm going to talk to you a little bit about what we did to optimize Kriegers for the iOS devices, moving kind of from the high level, dealing with Unity callbacks, all the way into shaders and software engineering paradigms. So let's talk about conditionals. Conditional constructs are used in Unity to say, run this code path on mobile, but don't run this code path on desktop, let's say. And you'll notice that the way Unity's built-in development suite, MonoDevelop, represents that. In this case, MonoDevelop represents code that will be executed in black, and it represents code that will not be executed in blue as a comment, as you can see here. In this case, what I've done is I've told it, don't execute this code on the desktop, but do execute it if I'm Unity iPhone or Unity Android. Now, the other thing you'll notice that what I've said at the bottom is this is bad conditional usage. And in my opinion, it is. In my opinion, this represents bad conditional usage because as you go through your program, if you have a lot of these conditional statements throughout your program, it can represent weird pitfalls, alternate execution paths that you may not have expected to encounter. Weird bugs that flare up only on Android but not on iPhone. Why is that again? These can be very, very difficult to track down. So, what I recommend doing instead is packing these all into a static class. And this is the Muse platform class that I was talking to you guys about earlier. In Muse platform, what we do is we expose static Boolean properties to say, hey, is this Android? Is this iOS? Is this mobile? Combine the two. Now, this gives you a lot of flexibility. And one of the really, really nice things about this is you can set up builds. One of the builds we had to do, we had to capture footage for one of our publishers, and they wanted it iOS footage, but we had to capture it on the desktop. So what do? We just make this return true all the time. Suddenly, we're running an iPhone build on the desktop, and we had to change none of our other code. Everything just worked. It just clicked. And in my opinion, this represents a very strong proposition because it gives you a lot of flexibility. So you'll notice now, our new code path is just a normal conditional. We ask Muse platform, is this mobile? Handle touch input. Or we just so happen to have written a touch emulator for desktop. Well, now everything just works. We can capture all of our footage as though we were running on the iPhone on the desktop. Saved us hours upon hours of work. Because we didn't have to go through all of our other code and change these conditionals. Input parsing. Big deal. This is one of the biggest problems we had, and having good software engineering behind us in the beginning saved us a lot of trouble as we were moving to the iPhone. So you'll notice here that we're good boys and girls. We're going to Muse platform and looking to see if we're mobile before polling. Oh, we are mobile. Well, I'm going to get the touch count. Oh, the touch count is greater than 0. I'm going to do a hit test against a GUI element. This doesn't really represent what you're doing. This doesn't really tell you this is a jump button and you should be jumping. There's branches here. There's a lot of, this is what's referred to actually in programming as cyclomatic complexity. If you've got too many nested if statements, you're dealing with very high cyclomatic complexity. And that just means there's too many different ways your code can go. It's easy to lose track of. It introduces bugs. You generally want to avoid it. Good classes have low cyclomatic complexity. So what do? In my opinion, you split it up a little bit. Now, let's talk about it. So let's represent our actions as what they actually are here. We'll break it down into enumeration. We have unset as our default value, so we know when we're getting something that we haven't actually defined or we've done something wrong, let's say. And then we get into our actual actions here, right? Pack those into, now are you guys familiar with the concept of scriptable objects in Unity?
When you say scriptable objects, does that...
It's interesting. It allows you to...
Here is familiar with the scriptable objects.
Okay.
Nice.
Scriptable objects...
Okay, is that something I would use something like Lua to talk to? Are you talking about prop? Are you talking about dynamic?
I will say the terminology is kind of weird, because scriptable object here really just means usable by a script, not so much that it's scriptable by itself. However, what you can do with this is you can create a file in your project that now is represented by this. So you can edit these fields right in the editor, in an object exposed, not in the scene, but in the library. So you create a file in your library, in the project library, that now represents an action mapped to a key code. Now, of course, this is only useful for keyboard and joystick bindings, right? So your touch bindings, you won't have these. Your touch bindings will have to do something a little bit different. But your keyboard actions are now represented in the editor, in the library itself, in an extremely easy to get at and manipulatable form. And the reason I did it like this is to allow my game designers to get right at it. They didn't have to come to me and say, change this to S to make me a build, change this to L and make me a build. No, they can just go right in here, in the editor, in the GUI, click the drop down themselves and change the value.
And based on all of which you've said means, as a game designer, I can be, like I am, no knowledge of fucking programming.
Yep. You can just do it. Exactly. It's completely abstracted from the code, which I like, right? Because once you get down to the code, this is a double-edged sword, because once you get down to the code, it's relatively easy, right? So you set up what I refer to as an input driver. And this is basically just a collection, as you can see here, it's a list of bindings. So now you've got a mapping. You've got a mapping of all the actions in your game to all the keys in your game. Come over here to your old update loop, which used to be this really high cyclomatic complexity. If I'm mobile, check the touches. If I'm desktop, check the keys. Right? Nope. Now suddenly you're just driver, get button, jump.
Yeah.
You get that, right? Do jump. There it is. You got it. Now admittedly, and I'll be the first to admit, you've created a lot of structural back-end for yourself, right? And I understand that. That said, input driver, you'll notice, is an abstract class. This could be keyboard, joystick, touch, doesn't matter. Swap them out. Do it on the fly, right? Keep a collection of behaviors somewhere that doesn't get destroyed every level or something. All of these different input drivers, serve up the right one when it's needed, have this thing reference whatever that thing is looking at, and you're good to go. And again, in your consuming code, your calling code is now extremely simple. And in my opinion, this is like the most important part for cross-platform development. Keep your consuming code as dumb as possible. Have it ask something for an action. Don't go through the parsing problems, right? Have somebody else do that. Defer that code. Put it somewhere else and encapsulate it nicely so that you can serve up the correct thing per platform.
Aside from the cross-platform speed and functionality and economies, does that mean, because of the cleanness of the code you end up with, that when I hit the key, I potentially will have a faster response time in terms of my input and me as a player seeing feedback on the screen?
The claim could be made that my approach is slower. The idea being that now you're referencing more classes, you're getting more references. Well, it's more complicated. The old way was faster because it's more direct. And I would agree with you if we were writing our own engine in C++ and we were at the metal counting context switches, but we're not. At the end of the day, what we're doing is we're writing high-level C# code that even in the most mobile sense gets compiled down to machine code in some kind of weird ahead-of-time translation layer. Don't stress it, right? In my opinion, and in my observation, practically no slower, no faster. It's identical practically. And on top of that, it will save you so much maintenance time and allow you, most importantly, to have all of your code encapsulated in simple blocks that are easy to subject to optimization. So for example, when I wrote my GUI library, I went through one class to draw all of my images, right? I was drawing them on quads. Well, one day I realized that if an image had an alpha of 0, for example, I could just not submit the quad. I could just disable the renderer. One line patch, doubled the speed of my GUI. Easy. Pipe everything through normal, regular properties, regular APIs. You expose yourself to really easy to optimize classes that, in my opinion, ultimately you will benefit more from than saying like, well, I really want to avoid the context switch or the branch, right? Don't micro-optimize.
Does that mean when we get beaten up by potential investors in our games and they're banging on about, you know, CI/CD and fucking instant response to like the data from the consumers and they're not doing this and not doing that?
And I agree that's important. That's important.
All about porting.
But don't try to solve that by micro-optimizing. Structure your code correctly first.
Yeah, that's what I mean.
And yeah, exactly. And don't try to micro-optimize.
So in other words, yeah, again, it's good foundations which take a bit longer and are ugly for longer than people like, but long-term, rapid,
but it should never be ugly, and that's the important part.
And I use that more in terms of like you being able to evidence that to publishing people.
Sure. Because a publishing person doesn't want to see 4 files; they want to see 1. I'll grant you that, right? The better approach is 4. The better approach is 6 in some cases because now you've got 3 different input fields, right? And since I'm looking at just a dumb input driver, and this could be backed by anything, touch, joystick, keyboard, doesn't matter. That's good software engineering, and that's kind of where it all starts, in my opinion. So, with that, move on. And of course, all of these slides will be made available on the group. So don't stress the code too much, because again, I'll put it all up for you guys. Oh, hey, there we go. Now we're getting into a little bit of optimization at the lower level, right? When we went to the iPhone, the brass tacks, no bullshit, the iPhone is slow. Especially now that Apple's continuing to sell the 3GS, you got to look at the 3GS and say, I have to support the 3GS for 2 years after Apple stops selling it. That's what we're targeting. With that, we need to be kind of clever, because it really, really is slow. So what do? One of the big wins we had in Kriegers regarding performance was not updating off-screen objects. And this seems silly, but if you're cycling through colors on an object, don't cycle through colors you don't have to, right? Creates a material, you know, kind of behind your back, as it were, because the second you reference .material in a component, you're instantiating material, right? So it'll create materials behind your back that you don't necessarily need. Pushing colors to a material, even on the iPhone 3GS, is relatively slow, right? Don't do that. Instead, every component that has a renderer, or every game object that has a renderer attached to it, will receive an on-will-render-object message. Set your colors there. That happens after the culling pass, too. So if your object...
every update?
Yes.
Every update?
Every single time a draw is done, this happens after call. Right? So after the scene is called, any renderer that's still like available for rendering, the game object will receive this. So all the components of the game object will receive that.
Using this callback doesn't slow down you know, the behavior of the scene.
Doing conservative, of course, it will slow it down slightly. And I don't have all the details regarding how Unity maps function names, for example, to function references. I can say that the callbacks used properly are significantly faster, right? Especially because you know exactly the subset of you know materials or renderers you're operating on. This was a big win for us. On became visible, on became invisible for our enemies, our NPCs. This was huge. We saved ourselves a lot of trouble dealing with orientation, rotation, movement, all kinds of weird behaviors we could totally fake. We could just slide enemies up a hill, for example, when they were off screen, but when they were on screen, they kind of had to run and they kind of had to backpedal, and it was a process, right? So I just tracked the visibility state by either using this callback or skin mesh renderer.isVisible. It's just accessible all the time. Just ask your skin mesh renderer, am I on screen? If you're not, just don't be fancy, be stupid. Just slide the character controller. With on-will render object, setting material properties, transform properties. For example, we have sprites in our scene, a bunch of little essence modes that the characters pick up. We don't rotate them towards the camera unless they're on screen. Well, that's kind of a no-brainer, right? But that rotation application to the transform, relatively slow, because it involves rebuilding the matrix off the quaternity. Don't do it if you're not on screen. Enemies, don't do it. Define trigger regions with NPCs, with NPCs active if you're desperate. This was a big win for us again, but you can use trigger regions like this sort of just intelligently to decide like, well, I don't care about what the NPCs all the way at the end of the level are doing. I'm at the beginning of the level. Just be smart about it, ultimately.
Very, very quickly, like you're talking in a way like, for me, you make it sound like this is all very obvious. Coming into making a game, and if I'm not using this, does that mean that I save a lot of time if I don't worry, like I'm being lazy and everything is being on screen? It's a question of having like a lot of experience. Like, why wouldn't you do that off the bat?
It's setting expectations, basically. If we were not bringing this game to the iPhone, if we were only on the desktop, optimizations like this don't matter. The desktop will eat through it. Right?
So in other words, like if I'm not thinking about the future and hitting all platforms on the desktop, fuck it.
Right, exactly.
Okay.
Just go nuts, right? Character controllers on everything. The bonanza of static colliders. Yeah, absolutely. However, if you're ever going to the iPhone, you know, and Ite was you know, completely correct when he was talking about colliders earlier. If you're ever going to the iPhone, forget mesh colliders, you know, forget character controller, scrap it all, be smart up front so you can start testing this exact case. This case is really difficult because you don't always know when an NPC is going to need to become active. You don't always know when it's going to be on screen. There's a lot of manual testing involved in that, and if you can get that out of the way early and be intelligent about it early, you save yourself a ton of work on the back end to the point where, in my opinion, there's less work overall if you deal with it up front.
Can I just, like, sorry, I'll say this at the end. Can we come at question time? Can you remind me? Can we talk about defining trigger regions and NPCs?
Yeah, absolutely, absolutely. Well, everybody has touched on shader LOD at this point. This is pretty iPhone specific, iPhone/Android. Have you guys, who here has experience developing with OpenGLES, the mobile version of OpenGL? Okay, really quick, generally, if you guys are familiar with shaders at all, OpenGLES 2 mandates that if one of your shaders goes through the programmable pipe, all of your shaders go through the programmable pipe. It's very clear on this, and in fact, Unity on Android will refuse to render shaders that you've defined in the shader lab, the vertex pipe. It just won't render them. It'll throw them out if you're in ES2 mode, right? Because, well, obviously you had one programmable shader, so all of them are, right? The iPhone doesn't suffer this limitation. On the iPhone, you can actually get away with using the shader lab vertex shader and texture combiners. And what our evidence has found is that they are significantly faster than using their programmable brethren, and you can use them in mixed mode. In our case, that presented us with a kind of an interesting problem in that we had to serve the programmable side to Android, we had to serve the texture combiner side to iOS. We did it using the LOD system that Alex was describing earlier. In our case, 200 represents programmable, 150 represents texture combiner. So using that, we were actually able to squeeze a ton of frames out. So that's, I know that's kind of nitty gritty, but sort of an interesting counterpoint and side effect. I feel like this isn't something that's well documented that you can actually get away with that. And it is very weird, although. But yeah, if you're going to Android, don't forget to also write a programmable side. Ultimately, if there's one thing you can take away today, writing good, extensible foundation code is not always fast. In fact, oftentimes it's very slow. You'll say to yourself, well, I could just copy that conditional block that I had earlier, and now my character can shoot and jump. Why do I have to go through the trouble of writing all these input drivers? And I can't stress enough to you that down the line, next platform, next project, even if your code is abstract enough that you can consume it in another project, it will save you time. It's extremely important, and the more you can condense your code into individual consumable packages that do very little but do it well, the easier your code will be to debug, and the faster ultimately it will run. So that's the entire talk.
Can I play devil's advocate? Half my time I'm on the money side, the publishing side, and my job is to support you as best as possible. We never have enough time, we never have a budget. All the money people, kiss it down. From my experience, I got the fortunate chance to build Rage for Rockstar, and I got to work with Wolfgang, who publishes Show Direct, and I totally agree. What you're talking about, 99% of the world don't do. It's almost like, you know, the right path is the harder path, but long term, totally. I mean, we don't get given that time. This is assuming you've got like lots of depth, at the same time you've got designers coming to you, but can't really articulate and give it enough where you're like, what's the design? We're like, we can't really give you the design without the tech, right? And how do you move, like, are there guerrilla ways of minimizing like the sloppiness of your code on the premise you don't have time to be as clean as you like? that makes sense.
Yeah, no, it absolutely does.
A week later, to go through it and clean it up.
That's always tough. Because I'll tell you right now that when you do that, you make assumptions about the rest of the API. And you always end up doing this. We actually had this problem recently in Creepers. You will make assumptions about what a method does and what it will always do, and they will always be wrong. If you work slipshod and if you have two methods in Level Manager, let's say, one is next level and one is go to next level. What's the difference between the two? Well, one was a special case function that we put in there after a cutscene when we didn't want to display a graphic, but we did need to transition to the next level. Did somebody document that? Well, we were moving really fast. It's not always... you will end up tripping over your feet. And ultimately it will happen, right? Because the axe is always over our head. So what do you do to mitigate that? And the answer is, you never throw your code out. The code you did for that last project, I'll bet you could take 30 to 40% of it. Input parsing GUI and, let's say, basic NPC behavior. You could take 40% of that and bring it to your next project. Well, if you've got to clean it up a little bit along the way, yes, you should, and you're obviously going to have to tweak it and optimize it, but it should always be in a state where you can take that block that you have already made and utilize it. If it's your first project, it's going to be tough. I agree. There's no good answer, right? Because, again, you're going to trip over your feet.
I think, just to emphasize, there's a lot of value in minimizing bugs.
Right.
That you don't know where they're coming from. Right? And your QA team haven't spent time, and therefore, if we've got to now release our games for free, but we've got to somehow eat and capture these people, quality, like cleanliness is vital. So, flip side looking at this, we're all actually very good at what we do, but we are trying to pioneer, we are really pushing the hardware and trying to do some different games. So let's see where we're in situations where we just haven't done it before. We read the theory, we do these checks. So it's not about like I'm being sloppy and lazy and hard coding and and follow conventions, but we've not done it before. And we have to do it the first time to realise, criticise, get beaten up, 50% gains next time.
I don't have a great answer for you, because it does come down to speed of development. One of the things we suffered during Creepers was, and anybody who was there at Muse can attest to this, is you wouldn't see a lot out of me for a while. But then suddenly, one day you would come in and I would say, hey, by the way, all the special behaviors for the Creepers are done. All of the characters have their special abilities done. Why? Because I spent the entire time building up the framework. Because I knew that the second I had it done, I would have to change it. If it wasn't in a state that I could change it, I was going to kill myself. That's not a great way, I admit, in game design, always to do business. You want to iterate quickly, and you want to iterate often. As soon as you possibly can, you want to be dealing with gray boxes, and I do understand that, and I'm sympathetic to that claim, especially when you're under time-sensitive projects. Again, I don't have a great answer for you. My only thing is I would rather see a game come out 2 weeks late than a game come out that we're tripping over our feet, because that game absolutely and totally will be full of bugs that will
fucking nightmare.
Not only kill us at launch, but will kill us a month after launch. And this is my problem. Is that we'll be unable to add features because we're still tripping over
by
our
the time
feet.
we've got to launch the hell dates, we're knackered and we're due like a month off, and yet now we're having to come back in on a Sunday because it's
right. And what I attempted to do was mitigate this by coming in on Sundays, and it took its toll on me, but ultimately the game got done. Alex.
Yeah, just want to add something to this. It's not a perfect solution, but it helps, and every little bit helps in something like this. Aim for modularity in everything you do. Isolate a piece of functionality as much as possible, and keep it as separate from the other pieces of functionality as possible. And this is, of course, going to be very vague, and it kind of has to be, because this is about as general as you can be. But the further you are towards this ideal of perfect modularity, the easier it is to swap out one of the modules when something doesn't work the way you expect. And if you keep that in mind as a guiding principle, when it comes time to fix a bug or to use something for the next project, it's easier to take the little bit and with relatively little effort make it what you need now. And every time you do this, every time you transfer from one project to another with one of these little modules of 3 or 4 classes or whatever that do some very specific thing, it gets better and it gets more reusable for the next time.
Is it fair for me to say, if you have written good notes about what you just did and the parts you just took, was that
documentation is certainly part of it, but
I get like
honestly, for any experienced programmer, I would tend towards poorly documented but well-structured code is better than well-documented, poorly structured code.
Agreed.
Right. And my point actually comes down to this.
Yeah, no, I mean, I'm not a coder.
Right,
I see
for
10 lines of code, I see one.
Yeah.
Math, right?
Right, exactly. It's math. And in this case, you can actually read this line and it makes sense, whereas the line that we had come from, which was this doesn't make sense to anybody.
Yeah.
Which is why it's, you know, more important. And to Alex's point, this is what modularity comes down to. We finally standardized on a GUI library at our office for just this reason. Actually, Brian, you had something to add.
Yeah, the one thing you actually mentioned that I thought was interesting is part of the development process where the designers are coming to you and they don't actually know what they want. You keep changing the code over and over again, and I think this plays into what Alex just said, and we don't really have a great approach to this, but we sort of plan that we're going to write things twice. We're going to write them the time when the designers have ideas and we're just going to write junk, and then we are going to go back and refactor it once the design is in place and we know how the system is supposed to work.
So would that be akin to I'm going to make like an architecture model to scale out of balsa wood and sticky tape and here?
Yeah, basically.
And
then you're going to smash it. And if you don't smash it, and it's tempting not to smash it because people will say, well, it works. You're telling me it's going to take you a month to make it just work again. And that balsa model doesn't work. You can't live in that.
Yeah,
you can't maintain that for 6 months after the game or port into another platform.
Yeah. It's funny because I'm not a programmer, but I look at the car industry and I'm obsessed with virtual worlds, and I also look at how the brain works. Right? I think there's a lot in nature that can help us. And the reason why I have to care about this is how do I make it as cheap as possible and as fast as possible for the best effects? And I've been sort of thinking about it in terms of not like an LOD, but like where, and I still don't fully understand client server, right? But to avoid like how am I having as much information built in static, cheap, it doesn't give a fuck about anything else, and in the cheapest form by the camera or the LOD running over it, it's like turn it on, turn it on. And so I'm minimizing what I'm carrying around, therefore in terms of and this is because I want to do third-person shooters online with lots of people, and I do want good frame rate, and I do worry about small objects and collisions, and I do want to push the behaviours and the complexity of what's going on.
We just did this actually. We're developing an online game, and I'll say the first thing we did, the very first thing was we developed a structure in which to run the game that actually somewhat emulated Unity for our server solution, Photon. That's the very first thing we did before we even touched a line of game code. We said we need a good foundation, and we spent a couple months doing it. We implemented all the math libraries to do it.
So
that's where we had to start. It needed to start there because A, this isn't the last online game we're going to do, hopefully. And B, now that it's there and everything is consuming it in a regular way, we know where to go for bugs. They manifest themselves in the same way across all of our
Yeah, and I don't know if this is true, but one of the things that we get beaten up on the business side in terms of now, the new words of being a product manager, right, and e-tailing, right, and the life value, right, is the idea of, and it may not apply here, is the cost of bandwidth. Sand storage is super cheap, and right? When I'm actually online and I am socialising and playing against people I don't know or my friends, and there's a lot of communication, that's expensive. Yes,
yeah, bandwidth, storage, computational, CPU will be expensive.
Right, but no, I'm on the network.
Yeah.
So us as a host and provider, my cost per free user is 90 cents instead of 40 cents.
Right, and we see most of our costs come from CPU, if I'm not mistaken.
Okay. How much of the clean code structure you're talking about, right, can reduce those costs? 9, 10?
It's not perfect.